Hello, everyone. It's Eric from freelearner.how. I'm joined today by my partner in crime, Abe Foy.
Hey, guys.
And the founder of Squirrel Research, David.
Hi, everybody.
So the purpose of today's broadcast, thank you so much for joining us. I see we've got a good number of folks trickling into the live room.
Thank you.
Is to talk about the soon-to-be released Acorn FPGA GPUs, mining accelerators. David has been gracious enough to spend some of his time with us this afternoon to kind of talk through the product, talk through the release, help share with us some of the specifications and how soon we should all expect to see this product. So, David, I wanted to kind of kick off some of the questions with, maybe let's go back to some of the history here. Can you help us understand what was your inspiration for the Acorn accelerators?
So what's interesting is we actually started doing heavy FPGA work in the spring as we were looking at the graphics card market getting really, really constrained around January time. And we started working on some Ethereum-based products in the FPGA world and evaluating all of the different FPGA chips that were out there, everything from the V9P chip that's in the 1525 boards, all the way up to some crazy $40,000 chips, all the way down to just say, if you had an unlimited budget, what would be the state of the art be? And while we were doing all that investigation on Ethereum, one of the ideas that we were kicking around was actually one big FPGA with a lot of little FPGA helpers, right? There's a design that's useful in that fashion for Ethereum. And when we started looking at what we could do to make those little FPGA helpers, we actually realized that it would be a lot easier to just make one of those little FPGA helpers that just sat beside a GPU. That was what kind of led us into the Acorn idea. And when we realized that, we all looked around the room and said, this is what we should be doing, and this is what we should be focusing on. That helps everybody a lot more. So we got into, on Reddit, there was a conversation around this where we opened the conversation around FPGAs and GPU acceleration back in, and probably somewhere between March and May. When we did that, there was a lot of interest in it, and we really started going back and saying, can we build this? Can we actually make this cost effective for everyone? Hooked up with some people that had already had design experience making very small M2-based FPGA accelerators, and then kind of beefed up that design significantly and came up with the Acorn prototype. And then while we were working on the 1525 group sale, we realized that we needed to let everybody know that this was in development. It was never our intention actually to pre-announce this and to do such an early reveal of the Acorn. But once we saw all the conversations happening around FPGAs and small ones and big ones, we thought it was important to make sure what we were doing was known out there and that was going to be available before people started spending money in 800 different ways on things that might not have a big support system behind them.
Okay.
What's kind of interesting about that is you said around January, and I published my first FPGAs are going to take over 2018 for.
I think I remember reading this.
Yeah.
Oh, you read that? Nice, man. Yeah, so it's kind of interesting how we were all kind of thinking the same thing. I was going through the Bitcoin talk forums, and I have a little bit of that background just because I'm in education, and so having. It's just kind of interesting how we were all kind of reading the signs at the same time and saying, "Oh man, this could be something interesting." So,
hey, Abe, you've gone out of focus there.
Oh no.
Well, while you're fixing your camera, David, you've talked to us a little bit about some of your crypto mining endeavors. I was wondering if you might be willing to share a little bit more about the mining that you've done, that you've participated in, what kind of scale, what types of equipment that you've got experience with that sort of led you down this path.
So that's always an interesting question to answer because we do quite a bit of mining here, but we're not a farm, right? We're not set up for production farm where we just take the same design and we just tile it all throughout a giant warehouse. So we have around 1,000, a little over 1,000 GPUs on premise here at our main Squirrel's offices.
Wow.
But most of those are set up. One of the things we have is we have access to almost every GPU that was ever made. Okay. We started with our initial cluster, which we built back in 2015, that was not for mining. And I've spoke to this before, but it was a very large FuryX custom water block, massive liquid cooled system. So in one of our dev buildings, we actually have a sealed in soundproof glass cube that had 128 FuryXs in it with a liquid cooling loop that goes up into the attic above it and has two giant 36-inch by 36-inch 4-inch core radiators and
wow.
two 7.5 horsepower pumps, 200 gallons of liquid. It actually heats our entire building in the winter. That was our original HPC GPU acceleration project. And out of that, we started researching all of the different GPUs and their capabilities one way or another. And we kind of had that set up when Ethereum mining really started to take off, and it became worth doing that. And so we built up from there our internal mines and our internal evaluation of all these cards and technology. So we have several hundred cards that were built just in a small Ethereum Monero type mining scenario. And those are mostly RX 570s and 1070s, 580s, that kind of standard mining environment. But the rest of the cards we have are all R&D. They mine when they're idle, right? But it's for evaluating this stuff.
Yeah, so you said for HPC was a lot of the reason for that. Is there other applications that you use for that specifically, other than mining?
Well, if you look at what our primary business historically has been, it's in screen sharing, right? Wireless, low latency screen sharing, both in room and over the internet, and products we've had in the past. So we're looking at things like real-time transcoding. We're looking at things like various types of encryption acceleration. In between, we did a lot of R&D work in the kind of number theory space. We did some verification help with our cluster of the two largest known prime numbers at this point, Mersenne primes, as part of the GIMPS project. We've really looked at a lot of different places where we can push the envelope of the hardware performance, not all necessarily based on profit-generating ventures.
Okay. On the Acorn specifically, you know, one of the questions that I think a lot of folks have is, who do you think that this will benefit the most? Will it benefit the small single GPU types of miners, or is this something that's really going to benefit the larger farm operators? How does it compare?
So when we originally put together the Acorn Accelerator project, my expectation was that it was going to benefit the small miners. The individual miners, the people that had a GPU in their gaming rig that they could easily accelerate to have closer performance to what ASICs could have, or have efficiencies closer to the big miners. As I've watched the community explore a lot of these configurations and pieces, I'll still kind of maintain the same perspective. It's hard for a large mine that's not deploying from the get-go with Acorns to really get all the benefit of Acorns. But I think it's really actually the medium-sized home miners that benefit the most, right? Because their rigs are reasonably small. They were forward-thinking. They built them off gaming motherboards. They built them with more PCIe lanes and with maybe a little bit beefed-up processors. And that actually, they have the easiest time adding Acorn to their setup. Now, anyone that's building brand new rigs, of course, can consider the requirements needed to use Acorn acceleration with their GPUs, and it doesn't really cost them much more to do that from the start. But these farms that build out on big 1x PCIe 1.0 chassis and lanes, and they just tile them through a warehouse, they're going to have a pretty hard time just directly adapting to using Acorns in that setup.
That's cool. Well, and then for you guys, what are you doing on your side? Are you going to be boosting yours up too? I would imagine, right?
We are, and some of it's dog fooding. Something we always believe in is you use your own product.
Of course.
Right?
Yeah.
So we have a good mix here. About half of our systems were from HPC research, so they're X99 systems or Threadripper systems with kind of big CPUs, lots of PCIe lanes, and GPUs in them in kind of 4 to 7 GPUs per chassis. So for those systems, we should be able to drop Acorns right in in place of some of the M2 SSDs, switch to SATA DOMs or other options for, or just SATA drives, inexpensive SATA drives for boot drives, and be able to drop Acorns directly in. What's interesting is some of our mining systems are built on the B250 mining expert boards, which is not as bad as some of the boards are for adding Acorns, but it does require a little bit more work. So that's where we basically need to take the X16 3.0 slot on that, put an Acorn nest in it with 4 Acorns, and then put all our GPUs on PCIe 3.0 X1 risers in those systems. So even our systems aren't necessarily built from the ground up for Acorn, but they can be relatively readily adapted.
So yeah, so I want to go into 2 of the topics that you talked about. So one of them was you alluded to the Threadripper. So I wanted to, so I want to hear about this Acorn Threadripper possibility that's hanging out there. Actually, I'm even going to make myself a little note because I'm forgetful. And then the other side is just kind of like what the difference is. So so I've been developing a FPGA miner myself. That is, I have a few boards that I use around for various different projects, just because I'm in like the engineering field. And so
great to hear more people that actually have some FPGA dev experience talk about this stuff.
Yeah, so it's interesting because it's more like I am a energy engineer, and I took a class or 2 classes in FPGAs before they're like, okay, you need to know this so that we can teach you this wide breadth of info. And then like 10 years passes by and I've used them a handful of times, So I'm trying to get up to speed with Verilog and VHDL. Actually, I learned in VHDL, so so it's a lot more verbose than Verilog is, but it's nicer because when I have an error, I'm like, oh, okay, that's what the problem is, instead of...
Yeah, VHDL is very, very deterministic and very, very explicit. Yeah. Personally, I lean towards Verilog because I don't always need that, and a lot of times I'm working with primitives anyway for the FPGA.
Yeah, and it's so much faster to write too. It's so much faster to write Verilog. Yep. So for the people that are out there, though, you have the VCU and the BCU 1525, and then we have the Acorn. And I thought, why don't you tell the people the difference out there? Because I think everyone thinks that an FPGA are all the same. And one of the things that I got a lot of feedback, both negative and positive, when I wrote the article is people were like, FPGAs are junk. Those are something we did in 2012, which I guess in computer years is 100 years ago. And and they're like, that stuff's not going to help. And one of the boards I was referencing is I had an old Entrapoint CM1, Claremont's one. And so that's a cool board, right? It has 4 Spartan 6s on it, L150Xs on it, which is cool.
Yep, Bitcoin mining on that.
Right, yeah, Bitcoin mining back in the day, and it was great, but it's old. It's really old now. And yeah, it may not do a whole lot now. I actually did a little bit of testing. I ran a Blake. I did some Blake on it and did some Bitcoin on it. I actually did one on script on it. It did horrible on script because it only has 512 megs of RAM on it. So I guess what I wanted to just have people realize is that not all FPGAs are the same. And so I thought I'd turn it over to you so you can explain the differences.
Yeah, and keep in mind, the Bitcoin mining that was done on Spartan 6s and LX150, first of all, that's the bottom of the barrel FPGA, even then. It's maybe not the bottom of the barrel, it's kind of the biggest of the lowest line. Right. So I would put it out there like an RX 550, right? Class FPGA. Maybe that's a little stretch, but it's not the big giant FPGAs.
Right.
One big thing that's happened is between then and now, all of the tech has kind of converged on silicon sizing limits, and major differences have been made, right? The Spartan, I think, was a 45 nanometer design on the Spartan 6. Spartan might have actually been 90 because it's usually one behind, but I think it's 45 on the Spartan.
I think it might be 45 too, yeah.
Yeah, so if you look at the top of the line now, there's 16 nanometer ultra scale plus parts like are in the 1525, and the Acorn isn't even that advanced. It's a 28 nanometer part, but it doesn't need to be once you understand what it is. In fact, you could do useful things with an LX150 if you actually had the bandwidth to your GPU. The big issue is that they can't compete with a dedicated ASIC for a dedicated task. But the entire landscape there has changed as well, right? If an FPGA was going to be bad at something, it means that a GPU would probably be bad at it too, because there'd be it's only bad because there's ASICs that are much faster there. Right.
Well, but the nice thing is that we were talking about on our site is I actually had a couple of ASICs myself. So I had I don't know if you remember the nanosilicon Terminator 2s, Terminator A2. So I had one of those, and we had you know, some older of the Bitmain machines, and while the coin is low difficulty and everything is great, that thing is amazing. But you know, what's interesting is I had that machine for a while, and then when the big boom came, it actually started making more money again. I'm like, oh my God, this is amazing. And then as it started to taper off, it was like, you know, it went from $10 a day to blah blah blah, and then it went down to, you know, $1 a day, and then. But it's eating up a kilowatt an hour just to run, you know, those 5 boards in the machine. And the nice thing with our FPGAs is we can program them to change to something else. You know, we can say, oh, you know, Bitcoin isn't script, you know, Litecoin isn't working anymore. Why don't we do Ethereum if we had the memory? Or why don't, you know, why don't we go and we do this? And I really like that idea. I think that's one of the sexy parts of it. If you can get over the programming hump, that's one of the big challenges.
There's also parts of the FPGA where a lot of its development, the size of the development community. So many of the early FPGA miners were written by people that were very smart people, but came from other fields, and they laid out some FPGA miners for certain algorithms, but it's not the same as a company with a whole R&D budget and a team of engineers all hyper optimizing those algorithms. And there just wasn't the market size of FPGAs to justify doing that. So you had some private miners who still, I mean, look out there and you'll find that there are private mines that have been using FPGAs that never stopped, right? Because they had the engineering talent, or they were able to pay the engineering talent to keep it relevant and to keep the algorithms optimized, and to go after some of these coins that there aren't ASICs for and things like that. So it's not impossible to still use that older tech. It just, you're not going to be able to treat it like a GPU where you can just go download something great somebody wrote for you on the internet, pay them a 1% dev fee, and go to town.
Yeah, totally. Yeah, and actually just hooking, one of the difficulties I found was just hooking up CC miner, or, you know, any of them, just to be able to get to the serial communication was really difficult, because some of them, without recompiling it, a lot of times they just wrote it right out of the program, you know. So they have the source files there, but it's gone, you know. And so in the newer versions.
I've spoken of that before, and that's one of the things that it's a double-edged sword. I love it and I hate it about the mining community. Is you have all these wonderful open source miners with varying levels of internal code quality or whatever, but it's great. It's open source, everybody can fork it. And then there's no coordination or organization to upstream any of that. Mm-hmm. So you just have 500 different forks, and depending on what you want to do, you might as well have 500 different miners. It's 500 is an exaggeration, but that part really bothers me.
Yeah, not much. Yeah. Yeah. Yeah.
At the very least, get somebody to take on the responsibility of upstreaming those, so we have one great open source miner that is continually getting all these algorithm updates and everything merged in. And it's hard to do that because of just how fractured the dev community is in mining. And the dev to user and miner ratio is actually incredibly drastic. You probably have tens of thousands, if not hundreds of thousands, of actual miners out there per actual dev that's able to get in there and work on the miners.
Yeah, and even in my little article where I was just talking about the future and doing comparisons, people were really demanding, like, hey man, it's been 4 months, where's your miner? And I'm like, dude, like, it takes a while to do this by yourself. You know, 4 months, the average programmer in a company takes 4 to 6 months if they're not using some kind of C-based language interpreter. But
yep. And that's, if you look at the SQRL miner, which may yet get a name change before it's released, because not everybody likes the SQRL miner, roll off the tongue. But if you look at that, you've got our internal miner work, right? But we're supporting a lot of algorithms. So that's where we've basically kind of merged with it. There's more to that we'll talk about at another time. But we've got the entire minority team and the OGOT company team and everything, and all of their expertise coming in there too, right? So it's not just internal Squirrel's miner. It's bringing all of this expertise that's been out there for years, developing these individual tools and individual miners, and bringing that all together into one, hopefully, really great platform.
Well, and so can you tell the guys? I kind of derailed you. I really apologize for that. Can you tell me what the difference is between the Acorn being 100 to 200 LUTs versus the BCU or the VCU 1525 being 250,000 LUTs? What does that do, and what does the memory do, and why is it that this board can be on a PCI X1, but this one has to be on a PCI Gen 3 X16, and all of those have to be on Gen X16s, and those really fancy motherboards that you got that have 18 slots on it for GPUs, those aren't super helpful for FPGAs. I think that's actually a really big disconnect where people are like, well, I don't understand. It works for a GPU. Why doesn't it work for a FPGA?
It's actually a terrible, terrible thing that GPU mining perpetuated this X1 low bandwidth link, where for most GPU mining, if there was a USB port on the GPU, they probably just would have used a USB hub and a bunch of USB cables, because all that's going across that link is the instruction that says, hey, start searching this entire N1 space for a winning hash for a share. And the GPU only really comes back to say, I found one, or the computer tells the GPU, hey, we're on a new block now, so start searching in this new range. That's really all that goes back and forth. And you could actually say that to a GPU verbally and get the responses back verbally, and it would probably be enough bandwidth to get it done if that tech existed. PCIe 1X is overkill for that. But when you're talking about something like an Acorn, you're actually offloading real work. So every single one of those things that you're searching, all of that for, you need to actually exchange that data between the GPU and the Acorn for it to work well. And we're looking at ways to get those Acorns as close as possible to those GPUs with as high bandwidth as possible to accomplish that. Luckily, the algorithms that are in play today and the amount of work that they do on the GPU versus the amount of state they have to pass back and forth, something like PCIe 2.0, which is what the Acorn is based on for cost reasons, PCIe 2.0 by 4 lanes is actually enough bandwidth to keep up with most GPUs and to actually fully accelerate the hash chain of most GPUs on most of the algorithms that are out there.
So, David, I want to kind of segue one of the key questions here that I think a lot of folks have, and this is a great time to ask, is how does the acceleration actually work? How do you get these faster hash rates with the Acorn as it communicates to the GPU?
So that's a great question. And I use Ethereum to explain it because it's one of the easiest ones to explain, but the principle is similar on the other algorithms. There are parts of the Ethereum is basically broken up into 3 parts, which is catch-a caching, a bunch of memory hard loop, the DAG loop, the Dagger Hashimoto loop in the middle, and then a catch-a cache on the end. Mm-hmm. GPUs are very, very bad at catch-a caching. It's not efficiently done in instructions on a GPU. It's power intensive, and while it doesn't occupy a ton of the resources of the GPU in the long scheme, it forces the core clock to run faster and hotter through the entire operation. And it also just takes time and takes program space on the GPU. Without going deep in depth, every time you run a kernel on the GPU, it requires a certain number of resources, registers, and things like that that are in finite supply on the GPU. And a lot of those get tied up handling the catch-a processing on both sides of Ethereum. So the FPGA, even an old FPGA like your Spartan 6s, can actually do catch-it very, very quickly. So on the Arctic 7 chip that's on the Acorn, this little Arctic 7 chip right there, we can actually get, and with an optimized implementation, north of 1 gigahash of catch-it.
Wow.
Which you need 2 catch-it operations in order to do Ethereum at 30 megahashes, say a typical RX 570 type range.
You can get one, sorry, you can get 1 gigahash per second off of your little Acorn?
If you're actually optimizing that, you can get 4 cores in there, north of 250 megahertz each.
Interesting, because the BCU can get 17 gigahashes off of it, right? So, wow, that's actually really impressive for that little board. Is it because it's more logic based versus memory?
Catch-it is entirely logic based. Doesn't touch the VRAM. Doesn't touch any of the memory resources in the common mode. So it's entirely logic based, and there are also parts of when you really get down to optimizing these algorithms, you can't just write it in Verilog. You got to look at the primitives. You got to look at how the CLBs are constructed inside the Arctic 7 series things. You'll find that there's some primitives in there that can really help you eliminate a lot of LUTs in the implementation. So you can do that on the BCU as well, and I'm not actually sure if Whitefire's implementation takes advantage of all those opportunities. But the bottom line is, yeah, you can, for about 1/10 of the power to the FPGA core, you can get all of that performance out of the Arctic 7 chip. And that's really pushing the limit, right? And even a gigahash of catch-it isn't necessarily super profitable to do independently. But
so how are you splitting the algorithm, though? How are you splitting the code to be able to, once it gets sent to the GPU, for the FPGA to have the handoff?
So the FPGA, in this case of Ethereum, right, we don't need to do a gigahash of Ethereum. We need to do about 60 megahashes, which is a drastically lower part of the chip. And we talked about dual mining, where the FPGA can also be working on another coin while that 60 megahashes of catch-it is helping Ethereum, et cetera. That 60 megahashes going in and going out takes about all of the bandwidth of the PCI 2.0 by 4 link.
Okay.
And you have the Acorn sitting there doing the input catch-it and generating the 64-byte state, the 512-bit output state, and filling a ring buffer on the GPU.
Okay.
So that can write out the PCIe bus to the virtual address space on the GPU. You can pin some host memory. You can, or vice versa, the GPU can read it from Acorn memory. But there's different optimizations for different GPUs and how it transfers. But the gist of it is you basically have a ring buffer and you overlap them. So while the GPU is currently processing the previous round of Ethereum hashes, reading the catch-it straight out of memory that's in cache because it's a small amount, and processing the inner DAG loop, the Acorn is sitting there filling that next slot in the buffer with the next set of pre-processed catch-it. Meanwhile, the GPU gets to the end of its DAG loop and is writing all its results into an output ring buffer that the Acorn's getting ready to process and check against target N1s or target difficulties and such like that. So you've got these 2 ring buffers on input and output of the DAG loop, basically, and you're just overlapping the I/O. Those transfers in and out of GPU memory are happening from the Acorn across the PCIe bus. Meanwhile, the GPU is just running back-to-back DAG loop kernels against pieces that are already in memory. So that's kind of the technical explanation.
So David, what GPUs do you see the Acorn benefiting most as a result of that architecture?
So we've seen slightly better benefits on the AMD GPUs than the NVIDIA. And I don't want to lean one way or the other color-wise, but I think you would say that the NVIDIA GPUs are slightly more optimized architecturally right now as is, right? So, and they're slightly more power efficient, so they don't have quite as much room to see gains. So you'll see that particularly in X16R, and you can just look at the website numbers on the X16R performance, and you can see pretty quickly that the Vegas have a lot of headroom on X16R. 2.3 on a Vega 56 on a X16R on the 215 Plus. It's about a 2.55x improvement, which basically means you get 1.5 free Vega 56s by adding the Acorn. And if you look at the 1080 Ti, it's 1.76, right? Some of that's miners, right? The NVIDIA miners have been slightly more optimized than the AMD ones. So we're able to make up ground there on the AMD side. And then some of it's just architecture, the memory architecture and the CUDA architecture on the NVIDIA cards is already running fairly efficiently as compared to an FPGA.
What's the kind of recommended ratio of Acorns to GPUs as you look at these various systems? Do you have any kind of configuration recommendations or options?
So I break that down between the core hard algorithms, which is X16R, Layer 2, Rev 2, the ones that we've got the detailed charts up on the website right now, and the more memory intensive algorithms, different memory intensive in different ways, but memory intensive algorithms like Kryptonite. I'm going to clear this up real quick. Kryptonite V1 is the algorithm. Monero V7 is the fork of the coin that uses Kryptonite V1. I know I'm being pedantic about that. Some people have really got on me on the forum that we should call it Kryptonite V7 because that's what people think it is. Sorry, that's wrong. Maybe I'm pedantic. Monero version 7 uses Kryptonite V1 as the algorithm. I just can't bring myself to perpetuate something that's wrong, even if it's what people understand. Maybe over decades, if they keep calling it the wrong thing, I'll change. But that segue aside, to get back to your question, when you're talking about the core hard algorithms, it's actually pretty easy to take the columns on the chart on the website and look at the Acorn utilization. Let's just pick two examples to make this easy. So a 1050 Ti, right, on Layer 2 Rev 2 has 53% Acorn utilization. And that Acorn utilization isn't really about the FPGA fabric and logic. It's really about the bandwidth limit of the PCIe interface. So that tells me that one 1050 Ti is using about 50% of an Acorn's throughput. That means I can put two 1050 Ti's on there for no cost. Doesn't slow down either one anyway. But now, if you look at something that's more powerful, especially on Layer 2 Rev 2, you tend to be using all of the Acorn. Something like even a RX 580, you're using 100% of the Acorn's bandwidth to accelerate one 580 by 1.9x. So in that particular case, if you split that between two RX 580s, you're going to get the same 1.9x, right? Which means you get about 0.9 GPUs for the one Acorn. If you split that between two GPUs, you're still going to get 0.9 GPUs extra. It's just going to kind of distribute between the two GPUs. And the way that distributes is pretty simple. So I'll just try to explain it, and hopefully it helps people pass on the correct knowledge. But we just take the time that GPU is processing, and there's a certain amount of time that GPU can process in assisted mode, which is just running a completely different kernel that's reading out of those ring buffers from the Acorn. That's assisted mode. And whatever time the GPU can't get enough ring buffer fill from the Acorn, it's just running full normal kernels, just like it would be if you're solo mining. So you're never losing GPU potential no matter how spread out your Acorn is. You're always using 100% of the GPU's time, just whatever the Acorn can't assist because of bandwidth or because you've got it spread out on multiple GPUs or because of your 1x risers. The GPU is going to keep doing what it normally does.
That's good. So you still continue to get the best possible benefit. I do have, coming from the live stream, George Zubek asks the question, how much of a overall power increase on an improvement in hashes per watt can you expect to see?
That's a really difficult question because of how the Acorn boosts it, right? Hashes per watt, if you want to do the math yourself, you basically say that an Acorn on something like Layer 2 Rev 2 and X16R, the Acorn is going to be running full out when you're at 100% utilization. So let's assume that you've got that. Let's just say that we're running X16R on a Vega 64. You're going to add the full 15 watt TDP of your Acorn, and that's it. So you're getting 2.3x improvement in hash rate, which basically means you're getting 2.3 Vegas worth of hash for your single Vega, and you're adding 15 watts for the Acorn to provide that boost. You're not really taxing the Vega's power supply anymore. In this case, it's just the 15 watt extra. So you can do the math on that and say, whatever my hash per watt is on my Vega, I'm going to get that. I'm going to get about 1 over 2.36, about 1 over 2.2, I'd say, improvement in power consumption. The way around, hopefully that makes sense to somebody out there, but I kind of went a way around to say that, but you're only adding 15 watts to the total power consumption, but you're gaining 2.3x in hash rate. So if your power consumption was
4 cents a day. Yeah. Wow.
Yeah, well, I think this is kind of one of the exciting things for folks like us. Once your product gets to the point where we can get some demo units in our hands, is we'll be able to go and run some of those types of tests and post and share the data that we're seeing kind of on a full system, post all the data points.
Yeah.
Which I think that's kind of one of the big questions all of us, myself, and a lot of folks who are watching have is, what's the update on the production process, and how soon can we start to expect to see the Acorn ship?
And we're pretty much on schedule there. I'll talk to it in detail. So we expect the first Acorns off the actual final production line to be coming off and getting validation tested around Tuesday. All right. The long pole on this right now for those reviewer Acorns is actually the heat sinks that go on them. So as soon as we get the heat sinks locked up with those review units within probably the next week or two, we'll be able to get those review units out. I'm going to say on the long side, it's probably at least 2 weeks out before those review units will be able to go out fully validated with their heat sinks attached. Software side is about the same pace, right? I mentioned on Bitcoin Talk, we're a little bit behind on software, but kind of within the realm of expectation internally. Now, as far as production Acorns for the batch 1 August, we're expecting those to ship out the last week of August, right? So late August is going to be pretty hot, late August, just to set realistic expectation.
Does the Acorn have to use the Squirrel miner, or can you use CC miner and just use a serial communication like standard, or we have to recompile CC miner to get that to work?
So you can, all right, so here's one of my development Acorn boards, and it's got this little JTAG adapter to take off of it, which you might recognize. It's a little HS2 Digilant. I don't even actually know how to say that. Some words you only ever read, but that's the little JTAG adapter, right? So it's got a micro USB port. So if you're a developer, you can throw one of these on there. You can connect it to the JTAG port that's on the bottom of the Acorn right there. And you can directly, there's a little YORT on there as well, right? So you can connect JTAG and a little serial YORT to that, and you can directly mess with the Acorn, write your own bit streams onto the Arctic 7, mine with it with CC miner, what have you. As far as the GPU assist mining, right now, that's initially going to require SQRL miner. And that's not because we're trying to hide access for anybody, but it's just the reality of bringing up a product and the associated software stack without also adding all the overhead of releasing an SDK early and documenting that and supporting all the development community. That's happening in parallel. So there's 2 ways you can approach that. One, our bit streams for the Acorn will be available with some interface definitions so that someone can mold those into CC miner and adapt the kernels that are being ran there on the GPUs to utilize those. We'll also are working on a plugin interface for SQRL miner itself so people can add other algorithms to that. And then, of course, we're going to really publish the specifications for this so that someone can create a full miner bitstream stack to take advantage of the hardware. It's just going to take time for those other miners, time and people that are going to spend the work to do it, for those other miners to get up to speed to utilizing them properly. But we'll be offering as much support as we can to the community that wants to do that. One of the other questions that I should answer right in line with that, people have asked about kind of wrappers like Awesome Miner and HydroOS and EthOS and things like that. that currently just wrap existing miners within a nice interface and a management system. They'll be able to wrap the SQRL, Squirrel miner, people keep calling it, the SQRL miner in those. There is an API that will be working with those teams to expose. That API portion of it is a little bit behind on the development schedule. We've got to get the primary miner out first, but they will be able to wrap those. They will be able to put those into their management schemes. At the very least, they can run the UI in CLI mode and get their scrolling log and parse everything off and manage it the same way they would manage Claymore or Phoenix Miner or any of those other options. So the difference, of course, will also be providing full development community support for that.
All right, thanks, David. A couple additional questions kind of coming from the live stream here. Brian Gilmore asks, will installing and running Acorns on a rig increase the CPU load?
So as we're advancing kind of the state of the art, because keep in mind, these Acorns are relatively new even to our dev team, right? We haven't explored every corner of this. We're offloading more and more of the CPU load. So I feel more and more confident saying that it's not going to significantly increase CPU load because we're able to directly read and write between the Acorns and the GPUs. With that said, we're still standing by our requirements on the website with regards to making sure that you don't try to run 12 GPUs with a bunch of Acorns on your single core Celeron, right? That's probably is going to tax the CPU to a load beyond what you want. So I'll stick to the recommendations in the FAQ, but we are making a lot of progress getting less and less of that to actually require CPU load to accomplish.
All right, thanks. Next question coming from Dorian Gray. What happens when you have a Nest 2 powering GPU risers, but those GPUs cannot fully use the 2 Acorns? Will the Acorns then process other GPUs that are directly attached to the motherboard?
Yep. So the Nest X2G is designed so that you can put four GPUs that are basically each using 50% of an Acorn off directly. And that's about the ratio. When you look at a 1x PCIe 3.0, that's about equivalent in bandwidth to 2 of the 4 lanes on the Acorn in PCIe 2.0. Every generation kind of doubles in bandwidth, in effective bandwidth. So if you're not fully utilizing that on the attached risers, that's why the Nest also has full bandwidth out to your motherboard, can go across either the direct CPU lanes to other GPUs, or if you're behind the DMI link, can kind of bounce through the DMI link to your other GPUs. Short answer, it goes about both the risers and the PCIe edge connector. It can do both at once. There's nothing that magically limits it to just one or the other.
All right, thanks. Couple of fun questions that I know Abe and I have been hoping we get an opportunity to ask you. Can you tell us just a little bit about your company? Why the name Squirrel or SQRL, Acorns, Nests?
I think the Acorn Nests and the Acorn kind of played off of the Squirrel. So when we're looking at product name, there's a fun part. The Acorn, the technical name is an Acorn CLE 101 or CLE 215. Which is actually C on the Roman numeral, LE on the logic elements, and then the number of logic elements on the FPGA, if no one caught that. But the Squirrel name itself came from, we previously, as a company, operated under the name Napkin Studio. Originally, when we first formed, we've been a company for almost 10 years. It was the idea that you are implementing the design that you sketched out on a napkin at the dinner table and passed ideas around. And when we originally started working on screen sharing and started selling it into education, we decided to sell that under a different brand. And Squirrel had been a nickname of mine from back high school days long ago because I like to climb on things, apparently. So that's a little bit funny, maybe embarrassing. But so we just decided originally it was just going to be a holding company to own those products and sell them. So we just called it Squirrels. But then we ended up selling the screen sharing software heavily into education and in K through 12 education, teachers, squirrels, fun animals. It actually played out really well. So that's why the brand has stuck and built out from there.
Cool, man. Hey, Eric, how much time do we got? Just kind of curious.
We got to wrap it up here in just a minute. Maybe let's do one more quick question, and then we'll stop the live broadcast here. So, can you are you able to give us any kind of a teaser for what's coming next from Squirrel Research?
Yes. So I can teaser a little bit that Acorn is just one piece. I can tell you that there is an Acorn Pro that's in development. Don't expect it soon. Don't hold off on Acorns because you're waiting for the Pro.
Right.
But I think you're going to be really impressed with what comes down the pipeline with the Acorn Pro. If you think about Acorn as a 570, 1060 class GPU pairing, think about Acorn Pro more like a 1080 Ti or even a Titan XP class device. Also in the M2 form factor, right? Just a significant advance in technology. And then I can tell you that there's a couple interesting projects in play on the full dedicated FPGA side. People have heard us mention the Project Jungle Cat. I can't really elaborate on it except to say that it is a lot more powerful than a 1525, and you won't see the full power of it until next year, but hopefully we have some teasers out here within the calendar year.
All right. Well, thanks a lot for that. I think we're all eager and we'll be looking for some of those future product releases. But for now, it's all about the Acorn and trying them out. We really want to say thanks again for all of your time today, David, taking an opportunity to talk to the community, come meet with us today.
Yeah, really appreciate that.
Yeah, really appreciate it, and again, looking forward to it. Also want to thank everyone who's joined in for the live webcast. Lots of good questions coming through and a little bit of fun in the window. David, in case you're wondering, SQRL Miner is, we got at least a couple of comments. Mr. Dinky says he likes the name, so maybe we stick with it.
We have both for SQRL Miner. It was originally SQ Miner, but it was a little confusing with SQ Miner and SG Miner and all. Yeah, very close names. There's CC, CG, SG, SQ. We're trying to differentiate it a little bit.
Well, and what's kind of cool is, you can also go with like I'm squirreling all my coins for a certain amount of my wallet, so you can have your Nest could be your wallet too.
Yeah, I've heard some. You got to be careful on those. I've heard some interesting plays. So one of our partners in the 1525 deal, great guys, Tom and his team on the all mine side. I've heard a couple people come out, all mine, as in all your money is all mine. You got to be careful on those names. People will take it different ways. But I might have time for one more question if you got a good one to throw in.
I want to know about your API. So can you tell me about what your plans are with the API and how you're going to do it? And yeah, just, how sexy is this thing going to be?
So the fun part about the API that I can tell you is that it's going to be JSON RPC based, but we're not going to just require you to roll your own. There's going to be a client library that you can drop into it as far as the interface to. I got to be clear because there's two APIs here, right? There's the API into Squirrel Miner, right? You manage and control Squirrel Miner, and that's what I'm talking about with the JSON-based API that's going to give you full control of everything in the Squirrel Miner core. Something that I'm just going to geek out for a second about architecture here. Yeah. One of the really cool things about the Squirrel Miner architecture is it was designed from the ground up to be a very professional suite of software. So we've got our entire stratum layer portion of it that handles all of the different coin stratums and pools and such. We've got a core piece that is the controller layer, kind of coordinator layer, brings it all together. And then we've got all of the core hardware pieces to integrate into FPGAs, GPUs, CPUs, even potentially into ASICs. I know it's a dirty word, but to be able to handle all that integration into all the hardwares that may be out there, and then handle all the algorithms underneath there. But all of that is completely independent from the UI layer. So the API to command and control the miner, the command line interface, the nice little UI that we've got on it, all of that is very, very flexible, and we can just take that very powerful miner core and fully expose it through all those different routes. So I'm really excited about that. Give you full control over the GPUs, fans, thermals, voltage, straps in real time, all of those things. That's something that maybe that's a little surprise drop, is we can actually control all the timing straps in real time. You don't have to flash the BIOSes. There's some really cool capabilities coming down the line there.
I have one last question. Sorry, Eric. Is people are wondering that I'm seeing on the Discord, is it going to be, will it be available for Windows and for Linux? And is there severe, what I've noticed all my life, you know, for most production things, even when we're doing IT and in servers, we're all Windows based, right? And so I've done things in Linux, but it's not my strong suit. And it's a lot easier to get the FPGA running efficiently in Linux. It's just how it is. And it's a lot easier to program it. It's a lot easier to connect to it. And it's a lot easier to get better hashes. That said, do you see the same thing happening in yours, or is the Windows one going to be just as good and easy?
So we fully support. The nice thing about having been a software company that works on multiple platforms for the last decade is we have an entire stack that's platform agnostic. The entire core of this thing is just a build flag away from being Windows, Mac, Linux. We actually have a full miner stack on Mac as well. And you can actually use the Acorn off Thunderbolt on Mac. I don't think we're releasing that, so don't get too excited right now, but we have it internally. There are some pieces that are a little trickier on Windows, particularly with the Acorn, the driver, right? The driver to interact with the Acorn hardware. There's a whole hardware driver signing certification process, right, to get that easy to deploy. And let's just say Microsoft doesn't work on the same time schedule of development we do. So that's just one little piece that could be an iron in the works here as we ship on the Windows side. But as far as capabilities, we've done a lot of work to make sure that they're pair. I personally am a Linux side guy. I think it's a way better platform for building up mining on, particularly some of the shortcomings in drivers on the Linux stack. Because of us managing a lot of the optimizations, they're not really as much of an issue. So that excuse doesn't hold a lot of water, but I know a lot of people are just more familiar with one or the other. They want to use TeamViewer, and we're absolutely going to be supporting both sides fully. So
awesome, man. That's great. That's great to hear.
I'm answering these questions in a lot of words, and maybe the details are getting lost. But Windows good, Linux good. I like Linux.
Yeah. No, it was clear. It wasn't like Bill Gates is the devil and this orphanage is a scam or anything. It was very, very good. And actually, to the remark, that's not how I feel.
It's not religion on the actual practicalities of dealing with the different platforms. And of course, it takes time and energy on our side to support them both. That's why you won't see a broadly supported Mac miner. That, and Apple would probably be upset if we were encouraging everyone to run their GPUs at full bore. But I've gotten metal optimized kernels. They're an interesting experiment, but we'll keep that internal for now.
Sounds good.
All right, David, I want to thank you again. I know you've gone a little bit over, so we really appreciate you taking your time with us today. Again, I want to thank everyone for joining. Have a wonderful afternoon, everyone, and thanks again for joining us.
Absolutely. And other questions, please, if you're not in the Discord, jump into the Discord, just because it's great to build up that community of knowledgeable people. But other questions, just feel free to pump them in there. I try to jump in there periodically and at least make sure that no one's getting completely wrong information.
Yeah, and definitely see us on our YouTube channel, freehoarder.how, and also on our website, freehoarder.how, also for more info and updates and everything. So, and hopefully a review product coming down in a couple weeks.
Absolutely.
Right. So,
and if you guys get questions and things from the community too, feel free to reach out directly to me and to our team so that you guys can post up content that's got straight from the horse's mouth kind of answers on this.
Yeah. Thanks, David. You and Tom have been super helpful.
Absolutely.
All right. Have a great afternoon, everyone. Thanks for joining us.
Thanks, everyone.